Hello, I am back. My iPad froze and then everything froze, and so I had to leave you with that cliffhanger in the previous video. We were working on section 2.1, problem number 4, and we got almost to the very end, and that's when everything just froze, and then I had a meeting, so like I didn't have time to finish it right then. So I'm going to go ahead and finish it now. So this is the second video for section 2.1. If you haven't watched the first one yet, watch the first one, because we go through everything, all of this in the first video. And we're working on number 4 from section 2.1. And yeah, it's like all the way down here. And we got to like the very end where I was just gonna, like, I noticed that we had 3x minus 7 twice in the denominator. So all I was gonna do was write this 3x minus 7 quantity squared, and then that's the end of the problem. So this is actually the answer right here. So we'll do a couple more examples. But the next example I want to do is one that has that uses, there's actually an alternate definition of the derivative. And that's what numbers 7 and 8 actually use the alternate definition of the derivative. So numbers 1 through 6 use that first definition, the one that we just went over. And then numbers 7 and 8 use an alternate definition. So it's nice to know both definitions of the derivative. The one that I showed you earlier in the previous video, the one that's boxed right here in black, this is the one that's more commonly used, but sometimes the other one can be like more useful when in certain situations, like when proving certain rules for derivatives of certain functions, sometimes the other definition is more useful or like easier to use. So I'm just gonna write this alternate definition of derivative. That's what we're going to look at now. Alternate definition of the derivative. So I'm going to draw another picture. It's going to be just like the picture I had before. A curve. So just another curve and a point P on the curve and a point Q on the curve. And we know that like if I draw a secant line through P and Q, I know that the tangent line is the line that's formed as Q gets closer and closer to P, right? So the difference between this definition and then like the other definition that I talked about, the only difference is really the ordered pairs, like how the ordered pairs are named. So like the P, the ordered pair for P, we call that one, what color should I use? I'll use black. The ordered pair for P, we just refer to that as A and F of A. So P has ordered pair A, F of A. And then for the Q, the ordered pair we refer to as X and F of X. So that's the difference. So like with the other definition, the ordered pair for P was X, F of X. And then for Q was X plus H, F of X plus H. And then here it's A, F of A for the P, and then for Q, X, F of X. And then once again, if we use the slope formula, we can like write a I'm having a hard time finding words. We can write an expression that represents the slope of the secant line. So thinking of this as my x1, y1, and then my other point is my x2, y2. Using the slope formula, y2 minus y1 over x2 minus x1, I get f of x minus f of a, that's my y2 minus y1, over x minus a, that's my x2 minus x1. And then again, so the tangent line is the line that's formed as Q approaches P. So like the idea is that Q starts getting closer and closer and closer and closer to P. And it gets so close to P that Q ends up practically being P, so that the only point that we have is the AF of A. And so what is actually happening if Q is getting close to P is that the X value is getting closer and closer to A. That X value is getting closer and closer to A. So here is our tangent line, right? Sort of. There's our tangent line. And so what we refer to as the derivative, or, and this is just the alternate definition of the derivative. Alternate definition of derivative is, once again, we use this notation. So f prime, that little apostrophe, that we read that as prime. And then, but this time we just say a, f prime of a, because we're thinking of the tangent line at P. Tangent line to this curve f at P, which has the x coordinate a. So we write f prime of a, the derivative at a, is, and so I'm just gonna write the secant line slope there, because the derivative is just the slope of the tangent line, which is just the slope of the secant line, but I'm giving myself some room in front of it because it's the slope as we let x get closer and closer to a. So f prime of a is equal to the limit as x approaches a of f of x minus f of a over x minus a. So we'll do an example using this definition, and then I think we'll just do one more example using the other definition. So I'm gonna go to the homework. And we did one with a fraction for the previous definition. So let's look at this one, number 7, because it has a radical. I'm just going to take a moment to write this down. I'll pause the. So problem number 7 gives us this function f of x equals square root of 8x, and then we're asked to find f prime of 3. And so we're being asked to use this definition right here, this right here. And our a in this situation is the 3. So 3, notice that's where the a is. So we're going to just keep that in mind as I write everything out. So I will have the limit as x approaches, notice the definition, it says x approaches a, and our a in this case again is 3. So we'll have x approaches 3 of, and then f of x. So I'm using the definition. So right now I'm here, I'm at the f of x part. So f of x is this function that we're given. So the square root of 8x minus f of a. That's this part right here. And what I'm going to have is f of 3 right there, right? Because our a is 3. And f of 3 I get by plugging in 3 for x. So what that's going to look like is I'm going to have the square root of 8 times 3. That's my f of 3. Instead of square root of 8x, I'll have square root of 8 times 3, which is square root of 24, which I can simplify this, but I'm just going to leave it as square root of 24, just for purposes of making things not complicated. So we're just going to leave this square root of 24. And then in my denominator, I guess we could also simplify the square root of 8, right? That can also be simplified. We're just going to leave it. Just some people might not be able to, and so on. And in the end, we'll get the same answer. So in my denominator, I'll have x minus my a. Again, my a is just 3. So I end up with this right here. And I believe that is what you're supposed to put. Yeah, so it's just like saying, can you write out whatever you get, like the expression? So I'm going to enter what I just wrote. They have the limit part. And I'm just entering the rest. So this, make sure you highlight the entire expression to put it all over x minus 3. And so far so good. So they just want you to like use the definition and plug everything in. Okay. And then it says, after evaluating this limit, we see that f prime of 3 equals what? So now our job is to actually evaluate this limit, which means we're going to use the techniques that we used in section 1.2. Yeah, section 1.2. So notice that here we have a radical. So you might remember from section 1.2 that whenever you have a radical, notice, by the way, I should say first, notice, by the way, that if I do plug in 3 for x, I'm going to get 0 in my denominator. So I have to do some simplifying here, which is where we're going to do what I was about to say, which is section 1.2. We talked about like finding limits. If you see you have a radical, if you try plugging the number in, you get 0 in the denominator and you have a radical, then multiply by the conjugate. So I'm multiplying by the square root of 8x plus 24. Conjugate just means that you change the sign in the middle. So instead of square root of 8x minus 24, at square root of 8x plus 24. And I did a problem like this in the 1.2 video, and then there are problems like this in the homework also, where you're basically going through the same process. So now I take the limit as x approaches 3. And the thing about conjugates, like the nice thing about conjugates is if you multiply them, so if I multiply a plus b times a minus b, I'm just going to get a squared minus b squared, which is very nice. One other really nice thing is that if I multiply, let's say the square root of, I'm just going to say p quantity squared, the square and the square root cancel each other out, and I just end up with a p. So just using both of these kind of rules here, I can work this out pretty quickly, because I know that if I multiply root 8x times root 8x, that's root 8x squared. So I'm just going to get 8x. Isn't that nice? And then since I'm multiplying conjugates, I don't have to distribute everything. All I have to do is multiply the first terms. So I multiply like a times a, that's the 8x part. And then multiply the very last terms, the b times the negative b. So that's what I'm going to do next. Root 24 times root 24, I end up with minus 24. Yay! Because again, it's root 24 squared, right? Which just ends up being 24. So yay! And then my denominator, well, not as pretty. It's actually quite ugly, but we can live with ugly. And so that's what we have. And I notice something really nice. I can factor out in the numerator, I can factor an 8 out, because look at 24 is 8 times 3. So next, I'm just noticing if I take the limit as x approaches 3, Keep my denominator as it is, so this ugliness. Right? I can factor out an 8. That's the distributive law backwards, right? Like each one of these has an 8. Each term in the numerator has an 8 in it, so I can pull that 8 out, and I'm left with x minus 3. And the reason I said this was nice is because I also have an x minus 3 in the denominator, and that x minus 3 in the denominator is what was giving me a 0 in the denominator. So now I get to cancel out that x minus 3, and I no longer have 0 in the denominator if I plug 3 in. So that's why I was saying, oh, isn't that nice? Because it's nice. It is nice. So now I end up with just the limit as x approaches 3 of 8 over square root of 8x plus 24. And now I can actually plug in 3 for x. Isn't that beautiful? Oops, I forgot to write square root of 24 here. Square root of 24, there. So now I'm going to go ahead and plug in my 8 for x. I'll just do that in red. So I end up with 8 over square root of, I'm sorry, plug in 3 for x. I think I said plug in 8 for x, plug in 3 for x. I think I'm tired. It's the end of the day. That's what happens to me. 8 times 3 is 24. So I end up with 8 over root 24 times root 24, or sorry, root 24 plus root 24, which is 8 over, this is 2 root 24s, right? And now I can simplify if I want. Like, for example, I bet you I can just put the answer in like this. Like, I bet you they'll just accept this, but I can simplify. So like one thing I know is that 2 goes into 8 4 times, right? So I can write this as 4 over square root of 24. And then another thing that I can do is I know that 24 is not a perfect square, but 24 is a perfect square times something. It's specifically 4 times 6. And so I can actually take the square root of the 4. Because I know the square root of 4 is 2. And now I can once again simplify, just noticing that 2 goes into 4 2 times. So I end up with 2 over root 6. So I could enter my answer like this also. And then some people, I don't care, but some people are really kind of sticklers for rationalizing the denominator. So if I multiply both of these, both the numerator and denominator by root 6, I can get rid of the radical in the denominator. But again, that's just some people care. A lot of people don't care. So I end up with 2 root 6 over root 6 times root 6, which is just 6. And then this reduces because 2 goes into 6 3 times. Oh my goodness, this is just... So you could also enter the answer like this. If I didn't do anything, if I didn't mess up anything, like if I didn't make any mistakes. So I'm gonna try entering these in all these different forms and see what it accepts. So I'm gonna first do the one where I didn't do any simplifying. It took it. You see? It's fine. It doesn't care about the simplifying, and I don't really either. Like, the point is I want you to get to the I want you to use the limit and get to your result. And then I'm gonna put in my other forms just to see if they'll take the other forms also. So it took that one also, and then I'm doing this one just to make sure that I did not make any mistake when I simplified, when I was rationalizing the denominator. Oh, so much. Okay, so those are all good. Last of all, it says find the equation of the tangent line to f of x where x equals 3. And so now it's asking us to find the equation of the tangent line. And this is really important because this is reminding you that this number that I just found, this root 6 over 3, that represents the slope of the tangent line. So that's like, this is your reminder that this number represents the slope of the tangent line. The derivative is the slope of the tangent line. So when they're like asking you to write the equation of the tangent line, you know, when you write the equation of a line, you know, it's y equals mx plus b. Well, we have the m part. Our m is what we just found, or what I just found. So this is the m. Yay. So now we just need to find the b, and to find the b, we're going to use, we'll use a point on our function, on our curve. So let's go to our curve and notice that our curve is f of x equals root 8x. And in order to find like a point on our curve, use the number that they give us, because they're asking us to find the equation where x is equal to 3. So we're gonna plug in 3 for x to find a y value. So we will have f of 3 equals, and we'll have the square root of 8. Sorry about my writing. 8 times 3. Or in other words, the square root of 24. So I'm going to go back to the iPad and write out this information. So I just wrote the information that we just got. First of all, that our slope m is the square root of 6 over 3. And then second of all, that f of 3 is the square root of 24. We can actually rewrite this, like just using this same breakdown. I can rewrite this as root 4 times 6, and then take the square root of 4 and end up with 2 root 6. So I'm just going to do that, which means I have the ordered pair 3 comma 2 root 6. This is my x and my y ordered pair. And then I'll use y equals mx plus b, and back to algebra, find the equation of the line, right? So I'm going to plug in the 2 root 6, I'll plug that in from my y. At this point, I'm trying to find out what my b is. I'll plug in, I'll plug in root 6 over 3 for my m. That's right there. So this is root 6 over 3. And then I'll plug in 3 for the x. So this is times 3. And then b is what I don't know. So this is plus b. Notice the 3's cancel out. That's so nice, isn't it? And so all I'm left with on the left side is 2 root 6. And then on the right side, root 6 plus b. And last of all, to get b by itself, I subtract root 6 from both sides. So these cancel. And I have b equals 2 root 6 minus root 6. And we'll just leave it like that. Or actually, sorry, we won't leave it like this. Notice these are like terms. So this is 2 root 6. It's like if you had 2x minus x, you would just say this is equal to x, right? Because you recognize that there's a 1 in front of that x right there. So 2 root 6 minus root 6, recognize that there's a 1 in front of this root 6. And so this ends up just being 1 root 6, or in other words, just root 6. So b is just root 6. And my equation, y equals mx plus b. Where's my m? My m is circled in red up there. So my equation, y equals mx plus b, I will have y equals my m, which was root 6 over 3 x plus my b, which ended up just being root 6. I just wrote it here. And here we are. So I'm just going to enter that, make sure I didn't make any mistakes. Y equals root 6 over 3 x plus root 6. And if you want to stay, I will do one more example. Let's do problem number 6. If you're not able to do it, then stick on your own homework, stick around right now and watch problem number 6. I'll work through it. So I'm just gonna pause, write it down. So for number 6, it's telling us that L of t represents the location function of an object. So it represents where an object is, right? And then it says we're computing the instantaneous velocity, which is the same thing as the derivative of this object at t equals 4. So notice, like in the, so we're going back to like just the first definition of the derivative that I gave, f of x plus h minus f of x over h, and taking the limit as h approaches 0. Notice here they put a 4 here instead of just an x. So like they're plugging in a specific number for the x. Notice they did the same thing for problem number 7, like plugging in 3 for x. So you can find the derivative with specific numbers, or you can find the derivative like just as a general function. And that's what we did for problem number 4. But now looking at number 6, so it asks us to find L of 4 plus h. So I wrote that on the iPad, so we'll go ahead and do that. So what this means is I need to plug in 4 plus h for all of my t's. So I will have 2 times 4 plus h quantity squared plus 3 times 4 plus h minus 4. And that equals 2 times 16 plus 8h plus h squared plus, and then I'm going to distribute this, 12 plus 3h, and then I have minus 4. And I want to just make sure that everybody knows how I got this part, this right here. I'm just using this formula. A plus b quantity squared equals a squared plus 2ab plus b squared. That's the formula I'm using. That's how I'm able to do it without having to go through a lot of drama, without having to do a lot of work. Let's just use that formula right there. If you don't know that formula, it's fine also to do this, 4 plus h times 4 plus h, but I like using the formula because that saves me time, right? So that's how I got that. Just want to make sure everybody knows that. So from here, I'll go ahead and distribute the 2. So I end up with 2 times 16 is 32, 2 times 8 is 16h plus 2h squared, and then I have plus 12 plus 3h minus 4, and then let's combine like terms. So let's see, I have 2h squared. I took care of that. That doesn't get combined with anything, right? But I can combine the 16h and the 3h. That gives me 19h. And I can also combine the 32 plus 12, that's 44, minus 4 is a positive 40. So that's what I get for that. And I'll just enter this. So this is what you'll enter for the answer. Well, what I'll enter for my answer. Yours will be different. So I have 2h squared plus 19h plus 40. So there's our first part. Then it says we'll compute and simplify the average velocity. So that's the slope of the secant line, average velocity. So I'm gonna go back and write that down. Okay, so I wrote that down, and the L of 4 plus H, we found that already, which is so nice. We found that that is the 2H squared plus 19H plus 40. So this will be 2H squared plus 19H plus 40. And then the L of 4, I have to like do some work for that. I have to actually plug in numbers. So for the L of 4, I actually have to plug in 4 for t. And I'm using the original function that we were given. So I have 2 times 4 squared plus 3 times 4 minus 4. And then this is all over h. And then from here, let's see. 4 squared is 16. 16 times 2 is 32 plus 12 is 44 minus 4. So all of this ends up being just 40. So I just did the math. All of that is 40. So I end up with 2h squared plus 19h plus 40 minus, and then all of that ends up being 40. And all of that in the parentheses. And then this is over h, and you'll notice that the 40s cancel, right? They cancel each other out. So all I'm left with now is 2h squared plus 19h over h. And you'll notice like you always, like there's always something to factor out. So notice in the numerator, both of my terms have h's in them. So I can factor an h out, and I'm left with 2h plus 19, and then this is over h. So recognize that 2h squared is 2hh. So if I factor an h out, I'm just left with 2h. And then notice the h's cancel, and I'm just left with 2h plus 19. This is what I will enter as my answer for that part of the problem. And then I think there was one more part. So this is 2h plus 19. We're almost done. And then the last part, it says the instantaneous velocity is the derivative. It's the limit as h approaches 0 of this 2h plus 19. So all I have to do now is plug in 0 for h. So I will end up with 2 times 0. So I just take the answer that I got and I plug in 0 for h. I get 2 times 0 plus 19, which is 19, and that's my answer. And I'm done. So I hope that helps. Take care, everybody. Bye.